Hi, thanks. So my name is Tomáš Nováčik, and a few months ago my team was tasked with classification of web page data into hundreds of new categories. And in today's talk, I'd like to walk you through the motivation behind this task, our approach, and ultimately the production pipeline that we've built. And yeah. So yeah, again, my name is Tomáš Nováčik, and I've been leading a data science team that focuses on personalization for past 2 years. And before that, I was a data scientist and a big data developer. And no. Yeah, here we go. It's a bit like, yeah, and okay. Anyway, so at the beginning of the presentation, I'd like to talk a little bit about Seznam, its business model, and the motivation behind this talk. Then I'll move on to large language models and how we use them in our annotation process. Then I'll briefly mention some modeling techniques that we used. And in the end, I'll describe the production pipeline and try to summarize the presentation. Yeah, it doesn't seem to work. Or it does, but there's certain like, okay. Sorry? Okay, thanks, okay. Anyway, okay. Yeah, so Seznam.cz is a Czech technology company and media house. We have about 7 million active users, and the product portfolio is quite huge. We offer lots of services, for example, search engine, maps, email. We have lots of content publishing websites. We have websites that compare shopping prices, allow you to inspect real estate offers, etc. And my point is that our users consume diverse set of content. And all of these services are financed through advertising, basically. And as an advertiser, you have two options in regard to your ad targeting. You can either target your ads contextually, or you can use behavioral targeting. So imagine you are an advertiser who wants to approach a sports-related audience. So in a contextual case, you may find websites that relate to this topic and place your ads there. And on the other hand, in the behavioral targeting setting, you would rely on the advertising platform, which would provide you with user interests, which might be like users who like sports. But it might not be only users who like sport. There are lots of different types of user interests. Users might be interested in dogs, performance cars, and loads of stuff. And basically, the behavioral targeting is more efficient and makes more money. And we were interested in making it better. So, yeah. Sorry. Yeah. Anyway, the behavioral targeting is inferred from your online behavior. What we do is we know what web pages you visited, and we try to categorize them into several different categories. There's approximately 300 of such categories. And once we categorize those web pages, we aggregate this data on a user level. And then based on the intensity and recency with which you interacted with a particular category, we compute user interest. And there's approximately 250 million web page categorizations every month, which means that there is approximately 100 categorization every second. And that's basically why we need to do this web page categorization task. And we need to do it on a large scale because we have millions of users and there's hundreds of million web pages. So that's make it interesting. And as I've already mentioned, we were tasked to support new categories. We were asked to support the new EAB market taxonomy that contains approximately 700 categories. It's a hierarchical structure with depth level of 4. And for example, there's this category business and finance, which splits into other categories. And certain categories are quite clear. For example, job market category might refer to users who are looking up information about job market, but some of these categories are quite mysterious and require some domain knowledge. For example, debt factoring and invoice discounting is a quite puzzling category for me. And we wanted to solve this problem using machine learning. And the first thing you need to do is to create a training data set. And imagine that you have a website and there are 700 categories. So it's quite difficult task to do it manually, and not only because there are 700 categories, but certain categories are difficult to understand or require some Googling around and talking to business people. So it's not an easy task. And in the past, we would used to build this website that allowed users to insert keywords, and the website would retrieve a set of documents. And we would use this approach to select representative keywords for every category. And this way, we would find documents that could be assigned to a given category. And this process was quite demanding. It would took us several weeks and involved lots of people. So naturally, we wanted to avoid all this hassle, and ideally, we wanted to use large language models. And we thought of 3 approaches at the beginning. We wanted to try zero-shot classification with prompting as a first method. As a second method, we wanted to try zero-shot classification with embeddings. And as a third method, we tried using large language model as a judge technique. And we were also interested in the overall price of this solution. Obviously, we didn't want to spend on it more money than what it would cost us to do it manually. And we also wanted to automate this process as much as possible. So in the future, if there were ever use case where we would be asked to categorize web pages, we could use this. And so the first sorry, guys. Yes. Okay, so in the first approach, we simply ask large language model to classify a web page for us. You can see the prompt on the slide. We just put there information about the website and tell it to classify into the specified categories. And at first, we use GPT 3.5. By the way, we used either OpenAI models or our internal models. So whenever I'm referring to LLM, I'm referring to these 2 types of models. And as a first approach, we tried ChatGPT 3.5, and we find out that the cost was $16,000, which was astronomical. And not only that, the cost was so high, we also find out that there were quite a lot of hallucinations, which we tried to fix by running this classification task hierarchically. So we would only classify the first level categories and then try the rest, but it didn't help. And once the GPT-4o Mini came out, we also tried as well, but the result was the same. The amount of hallucination this technique produced wasn't acceptable, but the cost was significantly lower. Yeah. So as a second approach, we tried zero-shot classification with embeddings. And in this approach, we created synthetic document for every category, then embedded that synthetic document and also embedded data in our corpus. And then run a similarity search, and based on Gaussian similarity, we tried to find best matching documents that we labeled according to the category to which the synthetic document belonged. And cost of this solution was quite low. It cost us only $60. And the synthetic documents were generated by GPT-4 model. We first generated description for every category, and based on that, we generated those synthetic documents. And intuitively, this is quite similar to the annotation process that we were running manually in the past, but instead of keywords, we used embeddings and synthetic documents. And similarly to that approach, this method yielded high recall, but probably the quality of the resulted annotations wasn't that high. So we were trying to figure out a way to improve this, and we stumbled across a paper that introduced a technique called large language model as a judge. And this technique allows you to score other machine learning models, other large language models, or basically any physical output. You just ask LLM to give you a judgment on some output. Ideally, you ask it to provide a score. So we ask it to give us a score between 1 to 5, and also the reasoning. And basically, we considered a score between 1 to 3 to be a true label, and score 4 to 5 to be a negative label. And if we were to run it across our whole corpus, this solution would cost us $1,000. So this was quite a lot of money, and we opted to use it with combination of the previously mentioned method, which worked quite well. Yeah. So we had this hypothesis and wanted to verify that they are working correctly. And unfortunately, we were forced to build a small training data set ourselves. And we created this annotation process where users were provided with outputs from these methods. So, for example, you can see how the LLM as a judge reasoning looked like. And users were then asked to just tell if this classification is correct or incorrect. And based on this data set, we concluded that the zero-shot classification with embeddings has precision of only about 57%, which is not acceptable, of course. But running on top of it, LLM as a judge improved this precision to 87%, which was really good. And we were surprised how good this approach worked. And the precision was increased even further when we considered only the score equal to 1. Then it increased the precision to 94%. So we were satisfied with this result, and we built a pipeline that looks like this. We first sampled 5 million documents, then tried to classify them via the embedding approach, which reduces the overall data size to about 150,000. And then we ran LLM as a judge, which reduces the training data to about 100,000 rows. The overall cost of this solution is only $90. So not only that we met the accuracy, but also the cost was significantly lower compared to other approaches. Yeah, and I would like to point out something. Basically, the generative approach alone wouldn't work because it would be too expensive. And on the other hand, the embedding-based approach, from the cost point of view, was all right, but it was too imprecise. And only the combination of these two approaches yielded satisfactory results. Yeah. And I find there similarities to how is currently RAG being perceived, which is also a technique that combines dense retrieval with large language generative abilities. And there's this ongoing discussion whether this technique will survive given the advances in large language model space, especially as the context window that large language models support gets bigger. And there's this paper by DeepMind, which was released this summer, that evaluate RAG versus LLMs. And what they conclude is that large language models beat RAG on almost every data set. But where the large language models fell short is the cost. They cost far more money compared to the RAG system. And in that paper, they actually try and build a system that uses both these approaches in order to mitigate the cost. But again, this is, from my perspective, the benefit of using the dense retrieval and generative AI. It cuts the cost down, and it worked for us, and it also worked for RAG. And in the future, if you are if you are facing an issue that can be solved by generative AI, I would suggest, if you are looking for efficiency, to try and employ embedding-based approach in the solution. Yeah, sorry. Okay, so back to user interest and training dataset. So what we received were annotations that we can use to train a machine learning model. And in this setting, one web page could be assigned a multiple labels. So this is a multi-label classification problem. And we decided to use a small BERT model to solve this. We used one that's freely available on Hugging Face. And as a features, we use URL, web page title, and web page content. We just concatenated those features and fed them to the BERT model. And we trained the BERT model in two scenarios. In the first one, we fine-tuned it for the classification task itself. And in the second scenario, we used only the embedding and then built a small neural network on top of it. Also including results from logistic regression, which we used previously, and also the zero-shot prompting results by two generative models. One is our internal model, and the second one is OpenAI GPT-4o Mini. And basically, the BERT, which was fine-tuned on this task, achieved the best F1 score and was ultimately deployed to production. And we tried many things to improve this basic setup, but we failed and never were able to beat this model. Also, this solution superseded the logistic regression, and you can also see that the zero-shot prompting results were quite bad, so I was quite happy that we haven't proceeded further with this approach at the beginning of the project. Yeah. As a result, we have an automated pipeline that is robust to categories addition and modification. What I mean by this is, if there were a request to support new category, we would just generate its description by large language models, also generate synthetic documents and embedded them. And that would be basically all what we would need to do. So there would be like 10 calls to OpenAI, and we would have new annotations for new category. So that's quite nice when you are using an embedding approach in this scenario. Yeah. Okay. And so based on that, we built a production inference pipeline. during which, in the first stage, we need to identify what web pages user visited, and we need to download that data. And for that, we use internal tool that gives us for every URL an HTML. And basically what we do is we apply a traffilateral library, which performs boilerplate removal. It extracts only relevant text from the web page. And we included this step because in the past we had some issues with data quality. In particular, we were faced with some new SEO footers which damage our classification. So this is where we try to build up the robustness of our data. And we are also checking the resulting distribution of text data and verifying that it is similar to Czech language distribution. If not, we discard this data and we use for classification only URL and a title. Once we obtain high-quality web page data, we ingest them into our feature store, which is built on Feast, and uses a ClickHouse database as an offline feature store. Once this data are there, we classify them by already mentioned model, which is deployed in a Kubeflow, and we use TensorRT for inference, and the model was built by a PyTorch framework. Once we have web page data categorized, we link them to user data and compute user interest, which we store in online feature store, for which we use Scylla and CouchDB databases, from where these data are then emitted to the rest of the Seznam. And from orchestration standpoint, we use Airflow and Argo CD. We use Kubernetes for compute, and we depend heavily on Kafka, as almost every component reads and writes data into a Kafka topic. And for data processing, we use a Flink library. And in this particular project, we used Flink not only to run streaming jobs, but also to run batch jobs. Yeah, and that's our production inference pipeline. Okay, to conclude this presentation, I'd like to mention again that basically the zero-shot embedding approach combined with generative abilities of large language model resulted in annotation that were cheap to obtain, very accurate, and robust to modification. This whole pipeline is automated end-to-end, so we hope that we can reuse it for future use cases. For modeling purposes, we use BERT, which is available on Hugging Face, and basically we couldn't beat the baseline with any additional techniques. Yeah, and I forgot to tell you that TensorRT improved significantly our throughput. So in case you are having a large machine learning model in production, you may want to use this, and it could probably boost your latencies and throughput a lot. And I would like also to mention that user interests are not only in an advertising setup, but are used across Seznam ecosystem for personalization use cases. And that's all from me. Thank you for your attention.
Tomáš Nováčik, thank you so much. And if I arranged it correctly, because it wasn't in the previous speaker, for you, I arranged the Slido on the big screen, so we don't have to look on this tiny little screen. So we're moving up in the world. Look at that. Imagine what we could do in OpenSlava 2025. So, of course, you can read, Tom can read, I can read, but still I'm going to read them through them, and we'll see what the answer is. So, why did you generate synthetic documents for the categories as opposed to sampling real documents from the category?
Yeah, so we generated synthetic documents because we didn't have any real documents for that categories, because that would require us to go through the data and manually annotate them, which we deem not worthy and wanted to avoid it. So it wasn't possible for us to do. We could do it now, once we have the annotation, but we couldn't do it at the beginning of the project.
Okay.
Okay.
Hopefully somewhere in this audience it answers your question.
So.
And then, Mr. and Mrs. Anonymous, what's your opinion on the Google plan to keep cookies away from advertisers, meaning you'll just get basic info? How would the behavioral advertising work if something like that goes true?
Good question.
You could think about it in the corner and then come back.
Actually, I like it that the Google tries to limit the use of third-party cookies, and for our use case, or particularly in Seznam, all those data that we have are in our own ecosystem, where we have sign-on, so I don't think it will affect us, but it depends on your use case and what kind of data you use for behavioral targeting, etc. So, yeah.
Okay. And didn't Google cancel those plans just out of own interest?
I think Google made them optional.
Okay.
Yeah, so the plan is not to cancel them out, but let users decide for themselves.
Okay, all right. So one gentleman here, no, they didn't cancel it. I work for Google, I know for that.
Yeah.
I'm just trying to pitch in here. Okay, thank you, Anonymous, for that one. And then just to summarize, the whole process of document generation, embeddings, and KNN plus LLM judge was used to obtain training data, which was used to train the BERT model. If it makes sense to you, you can answer the...
Yeah, that is way clearer probably than what I have told. Yeah, that's it. Yeah. So that's it basically. Yeah.
That's it. So the question is just for you to confirm.
Yeah, to say yes.
Okay.
Yes.
Cool. If no more, I'm looking at my Slido friend. We're going back up. Oh yeah, we're going back up. Michal, can you tell us more about your own Selma LLM model? Do you plan to open source it?
I'm not sure. The informations are freely available online. Those models are based on Llama and Mistral, and if you want to know more, just come by our booth, I guess. I don't know of any plans to open source it in near future.
Okay. And then I'm looking, do I look downstairs? Okay, it's going up and down. So we have Anonymous again. He's a very active user. Do you utilize also PyFlink in your pipeline?
Great questions. No. At the time, we use primarily Java language.
Okay. Short answers. Do we have any more coming? We're done. Okay, then I thank you very much for the questions and the engagements. I want to give you another round of applause for your talk. Thank you so much.
Thanks.